Alright, Biv, a former artist, figured that he needs $5,200 a month while retired to keep up blah 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 blah. So this problem is a reverse of our Maximus problem. Take a second, pause the video to read through it thoroughly. Do 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 ba do do ba do do ba 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 wah 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 wah. Alright, I'm assuming you read it. Here we go. Let's make a little timeline. So Biv plans to live 30 years past retirement, and then we also find that he'll be working for 34 years. He knows that when he retires, he wants to take out $5,200 a month. But what we don't know is how much he needs to put in so that he can take out $5,200 a month. So remember, for these types of problems, you will need two formulas, and you start with a formula depending upon the information you know. Since you know already how much he wants to take out, that's what we start off with. So we know the corresponding payment necessary to empty out the account. We just don't know what needs to be right here on the timeline in the account so he can take out the $5,200. So since during this portion he is emptying out the account, you want to think about amortization, but amortization is solved for the payment. We need to know the value of the account, where we already know the payment. And remember, that's your present value formula. So PV is going to be equal to PMT times 1 minus 1 plus R over N to the negative NT all over R over N. So for our problem, our PV is 5,200. Notice that he's expecting 10% while retired, so 0.10. And he'll be retired for, as we said, 30 years. And remember, when you throw it into the calculator, the denominator gets its own set of parentheses. I get 592,544.26. Okay. So this is how much he needs to have in the account at the time of retirement, which is here. Or is it? Unfortunately, this is what he needs to have in the account after being taxed 32%, which means he needs to keep 68%. So if X represents the amount that he needs in the account at retirement, 68% of that amount will be this $592,000 number. So mathematically, 0.62 times X, the amount he has to have at retirement, needs to equal this 592 number. And that implies that X, the amount he needs to have at retirement, pre-tax, is going to be $871,388.62. Yowzers. Okay. So now we know how much he needs to have at retirement. So now we need to figure out how much he needs to start putting away so that in the future he has this 871 number. Well, we previously learned about our future value formula. future value is solved for FV, where you know the payment, while here we have the flip. We know the future, we don't know the payment, so that's called a sinking fund. So in a sinking fund, you have FV times R over N over 1 plus R over N to the NT minus 1. So one more time. At this stage of the game, we're over here now. He knows what he wants to build up to, this $871,000 number. We don't know the payments necessary to get him that value. So this is a sinking fund, where you save up for a future debt. His future debt is going to be taking out money for retirement. So for us, we have this FV is this 871 number. R is this time 0.12. So notice in the word problem it says 12% return while he's working. Over 1 plus our R over our N. 12 times 34, because he'll be working for 34 years. So he needs to put in $152.99, 12 times a year for 34 years, and then he will be able to take out $5,200 a year for 30 years. Not too bad.